This next model is referred to as the means as outcome model, or regression of means as outcome model, where we have our independent or predictor variables only at level 2. And so in this case, this could help us answer the research question, for example, do schools that have high mean SES differ from those schools who have low mean SES on math achievement? Or do public schools differ from private schools on mean math achievement? So there's a couple ways we can look at this in our graphs. If we go to graph equations and model graphs, we can put in sector and mean SES here at level 2 in our Z focus. And I'm going to do the entire, well, I'm going to do, I guess, this would, 25th percentile would represent low SES, low mean SES, and 75th percentile would represent, high mean SES. And then when I graph this, you could see that those schools, for example, the public schools, those that have low SES definitely have lower math achievement than those that are in high SES conditions. The same way with public schools. You can see that low SES students have lower math achievement than high SES students. Now there's another thing we can do when looking at this graph, or this data I should say. We can put mean SES as our X focus and sector as our level 2 Y focus. And I'm going to do the entire range. And the reason it's different this time than when using sector is because sector is 0 or 1, whereas mean SES has a range of values. And so when I go OK, then you can see that public schools have lower math achievement in terms of their average math achievement across the range of schools than Catholic schools. They have higher math achievement. So this is another way that we can represent our data graphically when analyzing the data. This model represents the intercept and slopes as outcome model. And you'll notice that at level 2, we have sector and mean SES entered for both the, at level 2, for both the intercept and the slope, to model the intercept and slope for this data. And so what we want to see in our representation of the graph is how sector predicts math achievement when controlling for mean SES, and how mean SES predicts math achievement when controlling for sector. And so we're going to look at the intercepts and the slopes graphically for those relationships. And so if I go to File and Graph Equations and Model Graphs, I can put SES in at level 1, and I want the entire range. And then I'm going to put in sector at level 2, and I'm just going to use the actual two values, 0 and 1. And so you can see here is the intercept and the slope of the line, or the regression line that represents the intercept and the slope for Catholic schools, and the intercept and the slope for public schools. And you notice that the slope flattens out for Catholic schools as compared to public schools. So that relationship is sort of interesting in the sense that as high as public schools students have higher average SES, their math achievement is higher than for Catholic schools. Now, another way we can look at the relationship between these variables is to put in mean SES here at level 2, and we're going to look at low, medium, and high SES relative to SES. And so here we can see that schools that have high mean SES as compared to moderate SES as compared to low SES have different or lower or different predictive values for math achievement based on SES. And the slopes look relatively similar. So in this case, when we look at average SES, the slopes are, or the relationship between SES and math achievement is accelerating at about the same rate. And as we saw in earlier videos, schools that have high mean SES, regardless of public or private or Catholic schools, have higher math achievement. Now we can do one other thing, and this gets a little bit complicated, but nevertheless it's still telling. We can put sector at our z-focus at level 2 in this box, and we'll keep the actual 2 values. So what this does is it breaks out high, moderate, and low SES and its relationship to math achievement by public, which are the solid lines, and Catholic, which are the dashed lines. And you can see that, again, for all 3 socioeconomic groups in the Catholic schools, the slopes are flatter as compared to the public schools. But the relationship is similar in the sense that in the public schools and in the Catholic schools, the higher the socioeconomic status, the higher the math achievement.